Hello, I am Dr. Thanasit Kangkorn, plastic surgeon from Chonburi Hospital. I'm proud to present you all to the 3D Burn Resuscitation application.
We all know that the most important burn treatment is the right level of IV fluid resuscitation. It is commonly calculated using the modified Parkland formula by inputting a calculated percentage of total body surface area of burn. We can estimate the burn surface area by conventional methods such as rule of thumb, rule of nines, Lund and Broder chart. These methods are based on two-dimensional diagram, and this is not the actual body. The lateral surface measurement is the most affected limitation by two-dimensional diagram. In the conventional method, there are no differences in diagram for each gender and BMI group. Women's anatomy are more curved and shaped, and for men are more musculature. So these are not properly estimated by the conventional method, and the later consequences are over or under IV resuscitation. And the most important point is the conventional method mostly relying on the experience of the physicians. This is the study of burn size estimation and fluid resuscitation before admit to regional burn unit at Yorkshire Hospital, United Kingdom. 37% of patients had overestimation, 55% receiving more than 125% of recommended fluid. Smaller burns tend to be overestimated, and larger burns tend to be underestimated. These disadvantages led to the creation of the new computerized program for three-dimensional burn surface area estimation called the 3D Burn. It is based on a three-dimensional body scan of 6 selective volunteers, 3 men and 3 women, to cover all BMI groups such as underweight, normal weight, and overweight for each gender. This program is a co-development project between staff from Plastic Surgery Unit at Chonburi Hospital and the staff from the Faculty of Computer Engineering at Kasetsart University, with the help from the SCIENCE Thailand project at National Electronic and Computer Technology Center or NECTEC, Ministry of Science and Technology for Total Human Body Digital Scanning in developing a visual computerized model. 3D Burn program for PC and notebook was established since 2011. This program was first trialed at Chonburi Hospital. We developed 3D Burn program to be a 3D Burn smartphone application. It was established since 2016. The advantages about 3D model are rotated all direction by one finger, zoom in and zoom out by 2 fingers, no limitation to curvy areas and lateral side, matched to each gender and BMI groups, offline feature use, no additional equipment, paperless, and finally it's free download. The application is available for smartphone and tablet. You can free download from Google Play and also from App Store. This is an example of the mobile application interface. The user input patient parameters, which can measure in both metric and imperial unit, including weight, height, age, and gender, and the time since burn injury. 6 3D models differentiated by gender and BMI are suggested by the mobile app. There are 2 colors to select. The blue represents a second-degree burn, and the red represents a third-degree burn. We can zoom and move this model all directions, so any area can be available to highlight. And with this application, we can highlight any areas of the model. So the curve and shape on lateral side are not a major problems anymore. Once the physician had finished label, the program will calculate and report percent of burn surface areas by second and third degree in both numeric formats. The program will also suggest an appropriated amount of IV fluid resuscitation for the first 8 hours and the next 16 hours of burn treatment based on the Parkland formula. The application was studied for validation by Singapore General Hospital. They operated the research in annual meeting of second Singapore Burn Management Update in September 2017. They concluded the result and published in Biomed Central or BMC Burn and Trauma Journal, February 2018. Various healthcare workers were invited to use both the 3D burn application compared to the conventional methods in estimation burn percentages, the volunteer subjects. For the result, the mobile application group is more accurate in burn surface area measurements when compared to the conventional methods. In Thailand, we complete the prospective multi-center study at 3 centers of burn. First, Chulalongkorn Hospital, Bangkok, the central of Thailand. The second, Chonburi Hospital, the eastern part. And the third, at Chiang Mai University Hospital, the northern part of Thailand. To evaluate the accuracy between general physicians who use the rule of nines versus 3D burn application and burn specialists who use Lund and Broder chart and 3D burn application. General physicians use both rule of 9 and 3D burn resuscitation mobile application to calculate burn surface area at primary hospital before referred to burn center. After all patients were admitted to each burn center, both Lund and Broder chart and 3D burn application were used to recalculate the burn surface area by burn specialist. The result of this study shows general physicians using rule of 9 in evaluation of burn surface area are tended to overestimate comparing to standard rule and Broder chart. When using 3D burn application, the result is more accuracy. And there are no difference when general physician and burn specialists use 3D burn application. Conclusion: from two studies, 3D burn application could be useful in improving the accuracy of burn surface area measurement for various healthcare workers such as paramedic, firefighter, emergency response team, nurse, general physician, and burn specialist. It could be used to great advantage in early stages of burn management, both in the emergency department and in the burn center. Now, many people download this 3D burn application. This map demonstrated a distribution of worldwide download, such as Thailand, United States, Singapore, Germany, and Indonesia. I hope our free 3D burn application could be a step in the right direction of burn surface area estimation to reducing the complication from over or under fluid resuscitation. I would like to thank all my colleagues from Faculty of Medicine, Chulalongkorn University, Chonburi Hospital, Operation Smile Foundation, the Science Thailand Project and NECTEC, and Faculty of Computer Engineering Kasetsart University in designing and developing a 3D burn resuscitation smartphone application. Thank you.